So just to make it really clear, let me put my coordinate system. It is easy for me to do it this way. This is x-axis, this is y-axis, and this is z-axis. So what you see is actually what? A sphere on top of a sphere and so on. Concentric spheres of radius what? Square root of k. That is what it means. All right, do you guys get it?
Yeah.
Yeah, and if my picture is really crappy, it is taken from Stort's textbook. This is really the surface. Look, the innermost, and then the second layer, the third layer, and it will be really contouring and drawing that. All right. So now, with a similar token, if I walk you through this, I'm sure you can do this one. Okay. Find the level surface of f of x, y, z. All right, if I write it here, I'll give you the level surface f of x, y, z equals or defined by the function. This time, what I'm going to do is I'll give you x squared plus z squared. Okay, I take out actually y squared and tell me what the level surface is going to be. So what is your guess? What kind of surface is going to be this one?
A cylinder? Oh.
Yes, this is going to be a cylinder. The axis of symmetry is going to be what?
The y-axis.
The y-axis. That is really what happens. Do you remember when we talk about quadratic surfaces? A cylinder is a ruling. It doesn't have to be circular all the time. It can be opened also. But when you have really one variable is missing, that is really giving you a degree of freedom. So the ruling is going to be parallel to the missing axis. That is what it is really happening. So in this case, as you know, by making this one is equal to some constant k, and you have x squared plus z squared. And this is really what we need to have. So by making k is equal to, for example, 1, you are going to have a cylinder of radius 1 along the y-axis, if it is 2, and so on. So let us really draw it. So the first cylinder is going to be, I mean, you can draw starting at actually making the y value 0. Y value 0 means what? XZ plane. So on the XZ plane, we have this. And then now what will happen is the ruling is going to be extended. And not only in that direction, in this direction as well. So, and this is really the cylinder. So, and to indicate this cylinder is going forever, let me put scratchy ending to indicate that this is really going forever. That's it. And then now by making, for example, K is equal to 4, you will have another layer of cylinder, which is really coming this way. Yeah, I make it a little shorter so you can see it. One is on top of the other, and by making actually another one, we can really continue and doing it. Okay, you'll have another cylinder, which is really coming this way. By the way, all these are going indefinitely. So one is sitting on the top of the other. So what is really happening? If you have electrical field or magnetic field on each surface, that you are going to get is actually equal amount of current if it is electrical field. If it is energy, your magnetic field or something, it is equipotential also. Same actually magnetic field, whether it is on this surface or this surface or this on any part, as long as it is on the cylinder, it will be uniform. Likewise on the top one, likewise in the interior most one. Okay, I'll give you one more and then that will be the end of drawing level surface. Remember doing all this, guys? Okay, good. So let me give you one more example and then we'll do that. Why we need all this? We are going to need all this when we are studying whether it is a current, water current, electric current, or any, that is a vector field. And we are going to study those. And they are taking place over the space and time. So we have to really recognize all this. And that is really the important idea for us to do all these reviews. Okay, so let's draw these level surfaces. Now you have all the variables except the two are squared and one is linear. And what is really happening? How? Justified. Remember, this one, let us replace it with this. W, yes, f of x, y, z is single output W. Is that okay? And it will be x squared plus y squared plus z. So if we are drawing whatever x value you have and y value, you square it, but the z value is going to be linear. Then due to this, the fourth point is going to be replaced by this. So now to draw level surface, what do we do? replace this W by some constant K. This is, K is a number, R. Okay, if that is the case, we have x squared plus y squared plus z I have. Well, this doesn't help me really to draw the surface because it is defined implicitly. So why not we do it explicitly? So can I write z as a function of two variables, x and y? That means from k, I'm going to subtract x squared minus y squared. Is that acceptable, guys? So is this familiar actually curve that we are accustomed to, quadratic surface? Yes or no?
Paraboloid?
Yes, paraboloid, yes. And try to draw this paraboloid actually by making, for example, k equals, let's say 8, then k equals, for example, make it 4, and k is equal to 2, and k is equal to 1, and see what is really happening. All right, actually, instead of 8, why not you make it 9, this one? Better. Just for simplicity, it has nothing wrong with actually 8 also. Anyway, so I have to deal with this also square root. Okay, well, let us deal with k is equal to 1. When k is equal to 1, what do you have? Z equals 1 minus x squared minus y squared. Do we all agree with that? So when both x and y are 0, the z value is going to be 1. It is going to be here. And when z is 0 on the xy plane, actually the value of actually x is going to be 1 and negative 1, and y also 1 and negative 1. So you are going to have, and when you draw, actually you will have this paraboloid coming this way. All right. By the way, this is going down all the way. Is it clear? The first one? Okay. Now when k is, let's say 4, let us start with 4. And that is going to be actually 2. It will start here at 2. And then, I'm sorry, when k is 4, it's going to be starting at 4. 1, 2, 3, 4. And then it is going to be 2 here. So you are going to have actually a paraboloid coming like this one. Let me use a different color actually. And by the way, on the z-axis also, it will go this way. So you have this surface. All right. And then when it is 9, here it will be 9. It will cross the 3. And here also 3. Let me bring it. And here also 1, 2, 3. And then we are going to have this surface. One is sitting on the top of the other. So in other words, a ball or a basket is really sitting one on top of the other, turning upside down like this. That is what it means. Is it clear, guys? Okay, that is really what we need to know. If you have this, please remember, especially your on your textbook in this current textbook or on the previous textbook stored, we learn about quadratic surfaces, those 6 surfaces. Please really refresh them. So to make matter worse, actually, we are not going to deal only with function of 3 variables as input. We can make them 4, 5, 6, 7, n. And if we are struggling with 4 dimension, actually it is okay with 3 variables. We can make it a space object and the 4th dimension be time, so we can comprehend it. What is really happening? For example, if I have a box and then it is really carried away by a current, moving river, then we can really understand that the box is there and then the current is really moving it over time. So the location is changed. So we can really perceive the concept of 4 dimension. But when it is 5 or 6, to be honest with you, it is really very difficult. And one of the things that actually I can tell you is that one of the big assembling company we have here is Boeing, and it has actually it builds one time the for Air Force or Navy, I don't know. It is an aircraft, fighting aircraft, which cannot be jammed by radar. In other words, they want to deflect it, and they said it has 26 dimensions. But it is really, when they build it and so on, it is really sitting in 3-dimension hangar they have. So comprehending that concept is really very difficult, and I'm not trying to pretend that I'm an engineer, but that is the concept. When the ray is really happening, it is on that so many dimension of the skin, so the ray cannot be gathered and the radar cannot detect it. That is the idea behind it. Okay, function of any number of variables can be considered. Yeah, mathematics start with concrete and it stretches the limits. That is what is really happening. A function of n variable is a rule that assigns a number z, which is f of x1, x2 up to x7 to an n tuple, which is, look, you have ordered pair, triple, then quadruple, n tuple. So these are the input of real numbers. We denote this that by Rn, n dimension set of or such n tuples are taking place. For example, suppose for making a food product in a company, n different ingredients are used. And C sub I is a cost per unit of the ingredient. then XY unit of the ith ingredient are used. So these are actually examples of n inputs. So equation 3, then the total cost of the ingredient is as a function of n variables. So x1, x2, x7. Cost will be f of x1, x2, x7. In other words, the cost of the first ingredient with that first ingredient number. It can be 5 kilos, 2 kilos, and so on. And the cost per kilo might be here, or pound here in American system. And the second ingredient, it can be also, and it has its own cost, and you add all this. So this is really giving us what? A polynomial functions. So the function f is a real valued function whose domain is the subset of all real number. Sometimes we'll use this vector notation to write such a function. So the vector notation make it a little bit easier. So x, that means the number of the type of ingredient, x1, x2, xn, that means as a position vector, we put it. And we often write f of x, f of that vector x. By the way, I used bold. So in a place of f of x1, x2, x3. So to make it shorten. With this notation, we can write a function defined in equation 3 as the dot product of two vectors. Vector A, the cost of each input, and vector X, the cost of each ingredient, I mean the different ingredients. So C is C1 up to C7, and the dot product of these two is going to be a vector, and then the outcome is going to be a real number. Real number, dot product, as you see, it is a scalar, and you'll get a number. That is really what is output. So don't be surprised when we are studying vector calculus, the array of things, we are going to represent the multivariable function in terms of vector, and that's it. And actually, when you have vector in change and you analysis, it becomes tensor. But we are not going to talk about tensor at this class level. Forget about it. Okay. There is a one-to-one correspondence between the points in R3 and their position vector in Vn, n-dimension vector. So we have the following three ways of looking a function defined on a subset of Rn. In other words, in n-dimension space. One, function of real variable as x1, x2, x7 as input, or function of single point variable x1, x2, and so on, or three, function of single vector variable x, which has a component of x1, x2, and so on. So we'll see all of that 3 points of view are useful, and that is for further study. So for today, this is really what we need to know and what we need to do. I hope you have a clear idea about multi-variable functions, and we started with 2 variable. We head to 3 variable input, and then we go further to abstract form and variables, and actually to make our work more compact and actually easy to write. We can use the vector notation, and that we are going to see it in the future ahead. All right. I hope this will give you a clear idea or a hint while you are doing your homework and prepare for the next section. Thank you very much. If you have any question, I will answer. Otherwise, we are done. Okay, you too, guys. Please make sure that you finish your homework. They are really very easy and quick, and do them. Okay, thank you. Bye.